The meeting is being live stream.
Oke.
Okay.
Coba lo kirim gue linknya, coba bentar gue buka di YouTube.
Oke, ini belum setting up the meeting. Terus tuh jangan lupa record. Tadi gue kepotong tuh nggak sih?
Accidentally cut. Oke.
Oke, now you can chat.
Coba lo kirim gue linknya, coba bentar gue buka.
Nanti keulang. Pak, record. Tadi gue kepotong tuh nggak sih?
Delay ya di YouTube ya?
Heeh.
Accidentally cut.
Ke delay. Kemana linknya? Where's the link?
Share. Coba lo kirim gue.
Keulang.
Delay ya di YouTube. Accidentally cut. Share.
Nggak ada. Di mana linknya? Coba ini kali ya. Coba bisa nggak?
Di email gue.
Nih gue kasih di WA. Nggak ada.
WA.
Nggak ada share-nya. Benar? Coba bisa nggak?
Mantap.
Aku mau coba dari WhatsApp juga. Ulang-ulang.
Email gue. Bisa tuh?
Nggak ada share-nya. Ada udah. Oke. Benar?
Aneh.
Ini nanti kalau YouTube-nya live ini kan bisa harus di-cut, men. Benar? Berarti mesti di-download dulu, terus baru bisa di ini. Oke.
Bisa tuh?
Ya udah kita diam aja dulu kali ya.
Ada limitnya nggak nih live-nya?
Nggak ada share-nya. Kenapa?
Nggak ada limitnya kan? Berapa lama?
Nanti kalau YouTube-nya live ini kan bisa harus di-cut, men. Aku mau. Berarti mesti di-download dulu, terus baru bisa di. Oke. Unmute YouTube-nya, unmute first. Nanti ininya. Okay, what do I do? I have to send the link YouTube live here. Okay. Okay. Mana si Samer? Lihat kucing gue tidur, bukan tidur. Okay. Okay. Okay, that's done. Mhm. Okay. Yes. Can you let Summer in, please? Coco, where are you? More. Ah, okay.
Udah.
Udah. Okay. So, hi. Yang lain pada di waiting room nggak? I'm gonna start asking them to come into the waiting room. Hi all.
Hello,
Hi.
how's everything?
We have opened the room. Please start joining us. Are you there? Okay.
Yes, I can hear you.
I think you need more light for.
Okay, let me. This is better.
Yes.
Okay,
Okay.
you just also make something quickly.
Ernest, can you give me back as host? Reclaim host. I'm gonna reclaim my power. Okay. But I think I'm gonna already make Ernest as co-host, right? I already make you co-host, right? Yeah. Co-host. Okay. Okay, Ernest, you can admit people. Do you want to try your presentation?
Yeah, let's do it.
Okay. So this is high demand. We have decided to put it. We have a link on YouTube Live, and we've given it on the the email. But see, the thing that we are trying out is we did try to have 300 Zoom people, and then it's like then they don't come, you know. But
Yeah, that is totally normal, by the way.
right.
I've been like years making Zoom meeting. Yeah, that's
It's always
totally
like
normal.
that, you know. And then it's like 100, then people just, you know, they want to get in.
Yeah,
So,
I'm used to that. Expectations is something, and the reality is different, totally different. Yeah, when I make a public lecture, the registrants is about 200, 300, maybe more, but in the real life, they are not more than 25, 30 person. So
yeah.
that's totally normal. Yeah, for years, and I'm making public lectures, and that's the every time the same thing. So no worries, but it will reach. You know, just leave the recorded session maybe later on YouTube, and it will gain momentum, and it will gain people by time. People will get to know you more.
Yeah. No, people need to know all of us more and more space.
Yes, yes, we will. No worry, don't worry.
But it has started, you know, because I already told you your competitor, which is actually my friends here, they go indigenous tribal village, you know, they go way back into the jungle, you know. So, and I'm not saying it's easy, it's very difficult to construct something way in the jungle. But so it's kind of like two of the both extreme that I'm also trying to gather, right? Like in an architect forum. Unfortunately, my friend, their English is not as good. So terrible. But I mean, their work is fantastic with all of these indigenous communities. You know, they restore the traditional villages housing, and it's like with the community that do the construction. Then it's like, again, right, like it's all the culture and stuff, where space is totally the opposite end. So whatever.
So anyway, no worries. I'll simplify things. I'll try to speak more in simple English. And you look so pretty today. You are not so sick as I expected.
Oh, my head
You
is
look
throbbing. Oh my God. I don't know
no, no, no.
why. It's
You
like,
look so pretty today, and I'm glad that you are looking okay today.
yeah, thank you. I don't know why the second shot is horrible. My first Moderna was not as bad.
By the
you
way,
know.
I had 2 shots Pfizer. The first one was so peaceful for me, but the second one was terrible, the same as you. So yeah, I have been in that. You know, the second
Really?
shot, I had like a fever for 2 days.
Yeah. But like the worst part is I cannot really eat. I mean, I'm hungry and I need to eat. But then like when I'm eating, it's just not delicious, you know, and I'm like,
Yeah,
I don't lose
just
the
give
taste.
yourself time. Yeah, just give time to yourself, and you will be okay. No, don't worry about that. And don't even think about it. You know, overthinking might be the sickness.
Probably. That's my mental illness already. That's already my mental illness. Okay. So is there any video in the presentation? Should
I
we
don't think
try?
it will be. No, no, no. According to my experience, videos were not a very good idea in Zoom meetings. You know, because due to the internet connection and stuff like that. So yeah, you can post to them any video links if you would like to, but after the presentation, maybe.
Yeah, the lunar oasis is
Yeah.
already there. So I'm going to introduce you, Ernest. Where are you, Ernest? My cat is taking half of my table. Excuse me,
I'm
darling.
not a co-host, so I cannot let people in.
How come? I already make you.
No.
What? Okay, hang on. Make co-host.
We have 25 minutes to the public lecture, right?
Yeah.
Great.
But I'm asking people to join early.
So I'll let people in now.
Not
Can
yet.
I
not
grab
yet.
something real quick and be back in 2 minutes?
Yeah, sure. Do you want to leave the slide on full screen or whatever?
Yeah, I'll do that once we are ready and like that. Okay.
Okay. Yeah, sure.
Okay, just in a second, and I'll be there. I'll grab my coffee. That's all from the kitchen here.
Okay, sure.
Okay, in a second.
I need water too.
So I'll let people in and on later. I'll let
Nes nanti kan session antara si Samer sama si Thomas kayaknya recordingnya di stop dulu, terus nanti dimulai lagi gitu. Tapi kalau di stop dimulai lagi di YouTube-nya kepecah juga ya.
Iya.
Kong ya. Ya udah sekalian aja, berarti kita harus pecahin sendiri aja kali ya nanti ya.
So I'll let people in now or later.
Sekarang juga boleh kayaknya. 38 ya. Pelan-pelan.
Ya, gue masukin ya.
Tunggu apa sih? Tunggu si Samer balik dulu. Enggak.
Ya, bikin
mulai masukin aja. Kita mesti sisain buat si Thomas. Oh, gue join deh dari ini soalnya kita mesti sisain satu buat si Thomas sama Ratri.
Sisain 2 ya.
Thomas, Ratri sama satu saudaranya Ratri yang jadi co-host. Bukan co-host ya. Dia nanti dari IAI akan dipanggil. Namanya Reva siapalah. Pokoknya sisain Thomas, Ratri sama Reva 3. Sisain 3. Tapi kan ini baru 32 orang juga. I'm gonna start asking people to come in. Kenapa gue nggak bisa escape dari Zoom? Why I cannot escape from Zoom? Yes, yeah. Tuh udah kayak I'm still on the waiting room, let me in. Wow.
Udah masukin aja ya.
Ya udah. Hi.
Oke.
Section 3, space architecture. And section 4, Metaverse. Just starting soon. This register. Choice. Secure spot. Sent. Just to due to high demand of this action. Kyla, So how are you? I hope you are good in you're in Beirut, right?
Yeah.
So we already have 47 people. We have a bit of time. If anybody wants to have a bit of chat with Dr. Samer, turn on your camera to say hello. And we have some time while we wait for others to come in and introduce yourself, where are you all streaming in from and joining us from. Why do you join this session actually? What are you most interested about space architecture? Do share it with us if you fancy, or if not, okay, then you just have to. Is that okay? Again, if you are attending the webinar session with young kids, younger than 12 years old, please make sure they do not disrupt the session, because we need to hear our speaker and everyone else really wants to learn. So at least mute it. If you have any questions, put it in the chat box. Hi, Alimsha, Valeria, and Georgina. Thank you for joining from wherever you are. Let us know where you're streaming in from. And
Hi,
hi, where are you from?
I'm from India,
Oh, from India. Okay. Thank you for joining.
and I know Sir personally. I registered through him,
Ah, okay.
eagerly waiting.
Okay, great. Good to hear that. Who else?
Hi, I'm Georgia. I'm from Italy.
Oh,
I'm
wow.
an
Excellent.
hospital designer. I'd like to join this group. I'm very excited. Thank you.
Nice. Thank you. Good morning, Italy. I actually did my summer archaeology when in Rome back in when was that? Back in 2007. I spent a month in Trastevere for my archaeology and architecture history. I went everywhere in Rome and Ostia, walked the Appian Way. Italy is incredible for architecture.
Yeah. Yes.
Don't forget to turn your mic off. I'm gonna put you on spotlight. You. Why is it spotlight for everyone? Spotlight for Pin. Dr. Samer, are you doing any competition upcoming soon?
Well, yeah, I'm trying to focus now on the metaverse things There are several metaverse competitions. I think this is the new transcendence of our profession. So in parallel to space architecture, the real competition to the space architecture will be the new domain of metaverse things.
Yeah, of course. I mean, that would be very, very good if we
Yeah.
all can, it'll be a very good
It will
user experience.
it will not only be architecture or art, it will be assets, economic assets. You can build up spaces and start registering as NFTs and then start accumulating new kind of wealth, just like cryptocurrency.
Yeah, I think it's going to be also, especially in Asia. Yeah,
Yeah,
because
the new real estate.
yeah. Um, Speaking of democratizing space and making space accessible, I mean, even for some people, like zero gravity flight is the cheapest or most
Yeah.
affordable. But still, I wouldn't say we are third world country, we're developing country, but that's still a lot of money. And suborbital would be $250,000. That's still expensive. So I
It's
think
fortunate.
I think the best is through virtual reality. And we are also excited because we have lots of schools now is interested in our space education program, of which we of course would like to include virtual reality as part of the space education. So we're gonna start organizing headsets, and we are prioritizing the underprivileged schools in the regional areas. And some of our partners are ready to help, and they want to support the space education campaign. So it'd be great if we can show Lunar Oasis.
It all started on a virtual environment.
Yeah, in a virtual environment. And that's also like traveling without moving on a space travel.
Yes. I always say that the space tourism will start here from your laptop. I have this quote. It is a very important concept.
Actually, I mean, like, again, virtual reality and augmented reality, it's not new. It's but a lot of people still do not have the headset, right? And but technology is developing now, so it's going to be less dizzy. Like some of the headsets that I have tried, and then they have the ISS software bought from China. It's just giving me a lot of headache, and it was like a Soyuz capsule for virtual reality. But I'm excited to check out Axiom's virtual reality with Oculus to experience the
it's the new thing.
Space travel. Yeah, it'd be great. So Thomas is joining us later because
it will be a very exciting lecture. I would recommend all of the audience to attend it. He will be gathering both the metaverse thing and the space, and that's the interesting part.
Yeah, so Thomas, for everyone else, Thomas is also an architect, outer space architect as well. And so he will also go through briefly his space architecture portfolio of all the projects that he had done with ESA and NASA at the very start. And then he's going to start talking about the metaverse and Luniac. If you're in Prague or if you're in Europe and you can travel to Prague, it's free at the Virtualplex, which is the biggest virtual reality laboratory in the world, supposedly. You will have an experience of his metaverse design there. So do go. But we are working on bringing Luniac to Indonesia for Indonesian audience, hopefully soon.
Yes. It's a good thing that you have been so active in this domain. I didn't expect to find such an activity from Indonesia, actually. But you're doing a great job. Keep on that.
Thank you. Well, we try our best. I'm really happy with this all. I mean, like, aside from all of the bad things about the upcoming metaverse, but I think the virtual reality is going to be, it's a very good entry for us to educate people more about space, and especially in the space education, and again, like traveling without moving tourism. I think it'll be very good. So looking forward to work with all of our collaborative partners to make that happen here. Tom is here. Yay. He joined early. I think he knows who's been talking about him. Hi, Tom. Are you awake? I'm just gonna put him as, where is it? Tom, I saw him.
Yeah, it did so. He's on,
Yeah, but I can't find him on this. Where is it?
but I think he's not connected to the audio.
Oh, there you go. Okay, I'm gonna make him co-host. Yeah, it's okay. I mean, he's not on until another hour, but I told him to join our great. What are you kids doing? Hang on, my.
Lagi live? Enggak. Kalau mau di situ bisa.
Ah. 75. We should have music or something. Few more minutes. If they're late, we're not gonna admit it. Okay, Ratri is here. Ratri is my co-founder. I don't think you have met, but I want to introduce you, Ratri.
Actually, not hard.
And she's from a developer family. So architecture is right up her alley. Yeah.
We should go in like 2 minutes, right? Or 3 minutes.
Yeah. Hi, everyone. Thank you for coming. Don't forget to turn off your mic while Dr. Summer is presenting, so we don't hear it. If you have any questions, shout out on the chat box. Let us know where you're joining us from. And if you have any questions regarding space architecture, what would you like to know about building?
We are
on
now
the-
83. We are now 83 participants. See, they are growing up.
Yeah, 83. Not bad for a Saturday. So, I mean, cheers for everyone who joined. You have done yourself a great favor. Wow, very early from Norway? Nova Scotia, Canada. That's very early. It will be like 1 o'clock in the morning or something, midnight. Good on you. Indonesia.
Valeria from Mexico, the other part of the world.
Yeah, 3 a.m. Oh my God, I can't do that anymore.
Well,
Really.
we truly thank you for coming today and for showing up at that early morning.
The last time I was up until 3 o'clock in the morning, I haven't done that in a long time, was watching Manifest on Netflix. That is horrible. Oh my God. Suddenly everything didn't matter. And I was like watching it until 5 o'clock in the morning. If you haven't watched it, you should watch it. It's like Manifest is so fun. So, okay, 3 o'clock. I think we can start. But before that, I would like all of your permission to record this session. The recording starts now. Before that, need my co-hosts help to mute everyone else if they haven't.
Hi, Tom.
Oh,
Yeah, pleasure seeing you today.
nice to see you. Actually, if I stop the virtual background.
Oh, you have a lot of snow there.
Yeah. We just
Enjoy.
arrived through mountains. Yeah.
Yeah.
Is Tom there? I can't. Is he on? Okay. Okay. Record on this computer. Welcome everybody to our Moon Camp 2022. Thank you so much for registering and joining our third session today on space architecture and continued fourth session on Moon Metaverse. We're going to learn today from award-winning international space architects, Dr. Samer El Sayari joining us from Beirut, also Thomas Rosek from Prague. If you are interested in architecture and design, you will learn a lot from these two gentlemen, especially space architecture. Today we're going to go look at their portfolio. They're going to introduce us what is space architecture and how is it different from terrestrial architecture, and conceptual design about building a moon colony, living underground on the moon, in the moon, and the technology that enables it. But prior to all of that, before us getting there, and whilst the 3D printing technology is currently developing, the metaverse, which is now such a hot trending topic all over the world because of Facebook, that's now Meta. One of the brilliant way for us to, whose mic is that? Can you please turn it off? So good. And where was I? The metaverse. That will tremendously help architects in general, especially space architects, in simulating their design and and then us being guinea pigs on Earth, on actually having that experience before actually moving there. So today I'd like to pass it on to Dr. Samer with your presentation. Thank you so much for allocating your time and sharing your knowledge today. We have reached 100 people.
Yeah,
we cannot
great.
admit any more people in, but it's on YouTube Live. We've shared the link if they want to join us there. And the screen is yours.
Okay, thank you, Ed, so much for this opportunity. I think it's the magic of the 21st century to gather people from different continents, different countries to share the same vision about maybe our coming future. So my presentation today, I was so much curious and I thought a lot about naming the title of my presentation. So I decided finally to call it The Tale of a Planet, because, I'll be telling a story of a planet. But which planet? Is it planet Earth or Moon? If I may, please, can you turn off your mics, please? Thank you so much. So I decided to tell a story of a planet. I do believe that Earth, Moon, Mars, maybe they are all connected. It is the tale of the human race across all of these planets. So what to expect today? First of all, a unique knowledge, something new, introduction to space environment architecture implications, some architectural skills if you are an architect or a designer, or if you'd like to consider someday to be an architect or a designer, you'll be familiar with some of the architectural approaches in designing for space. And third one, I hope that it will be a motivating session for people to start designing for extraterrestrial environments. So I would also hope to inspire others to join us in this domain. I would like to start my presentation with a quote of Da Vinci. Da Vinci quoted that he told people to develop your senses, especially learn how to see. And when we are talking about seeing, it's not about using only our eyes or our direct visual conception, but to see behind things, to see the core of things, to see behind shapes, and also realize that everything is connected to everything else. So, why space architecture? Many people claim that it is a plan B for humanity. It is the extinction. We are preparing for the extinction level event. Earth has survived already or passed through 5 different extinction level events. And scientists claim that we are on the verge of the 6th extinction level event. So if something bad, for God forbids, of course, happened on Earth, will we be able to survive? That is a big question mark. Let's begin with Stephen Hawking vision. I don't think that human race will survive the next 1,000 years. Unless we spread into space, there are too many accidents that can befall life on a single planet. And this is the first point of view. I will be just presenting many point of views. The first one, talking about the extinction level event, was adopted by Stephen Hawking and many other scientists. But he is optimist. He do have a good understanding that we can reach out in another environment so we can survive. It's all about the survival of our race. But also, it's not a dystopian future. Some entrepreneurs, and some businessmen, world-renowned businessmen, have a utopian vision, like Elon Musk. Elon Musk has a dream or a goal, I might say, because he is not a dreamer, he's an achiever. He would like to make humans multiplanetary species. And when we talk about multiplanetary species, that means it's like different nations, but on a different planets. So you can find someday maybe the people of Mars or the people of Moon, the lunar nation or the Martian nation, and the Mother Earth, which will be, of course, the mother of all civilizations. But also another endeavor is the space economy. It will be the catalyst of the 5th industrial revolution. The 5th industrial revolution is all about space economy, space mining, space resources, space medicine, the evolving of the cryptocurrencies and the NFTs and the digital revolution that we are witnessing today. Our 4th industrial revolution is the foundation to the coming era, to the coming space economy. And one of those who thought about it was Jeff Bezos when he quoted that he would like to achieve with Blue Origin to build the heavy lifting infrastructure industries that allow the kind of dynamic entrepreneurial explosion of thousands of companies in space. And he also confirmed about making the Earth a green planet for our healthy habitation. And that also is a very important point of view. But also, why not having fun? The space tourism. And of course, the pioneer of the space tourism was Richard Branson. He already started making zero gravity tourism, but we can exceed beyond more the zero gravity and expanding into space and having maybe a resorts on moon or resorts on Mars or even a zero gravity kind of hotel, the kind that you can just have a relaxing vacation or a summer vacation or a different experience and start exploring new environments. And that is not only the only point of views. Also, we have a very important point of view, which is rejuvenating deserted Earth. So, in my opinion, in my point of view, we should be studying and developing for space, not only to explore space and colonize space, but to save Earth. It is the same science that will be using to colonize new environments that could be applied to reverse the climate change and to fight the climate change and to fight even any extinction level event. We are designing for the worst case scenarios, the lunar environment, which means on moon, designing on moon or designing on Mars. It is one of the worst case scenarios and one of the most harsh environments in the solar system. So by having this kind of knowledge and experience to design in those environments, we will be possessing a lot of knowledge and lots of science, even to save our race, even on Earth, in any case of an extinction level event. So this is my vision and mission. We have to develop and learn space technology. We will need it someday on Earth. So it is the same science, same plan to terraform Mars or to save Earth. So according to science, what are the potential sources of the existential risks? We have like 16 different existential risks. You can see here on this slide, like 10 of the existential risks are anthropogenic, or which means that it is man-made, from cyber attacks, by technology, environmental disasters caused by industry or an experimental technology, accident, something like collision, hydro collision, or maybe the global warming, all kind of weapons of mass destruction. We have many reasons to think that we, by our hands, could end life on Earth. But as also hazards and dangers are growing, also science are growing to reverse any kind of existential risks. Also, we have a non-anthropogenic, naturally. It's not only about our behavior and our conscious how to save Earth, but some events we do not have control upon, like the cosmic threats, like an asteroid impact, or like a global pandemic. We have all witnessed the COVID-19, and it was not a really big disaster. We survived, and just in a year or a year and a half, we have developed vaccines, but you don't know what is coming in the future. You can't anticipate. We can anticipate, but we have to put plans. So it is about building a new kind of space Silk Road, turning again to the space economy, while not making an interplanetary economy, interplanetary trade, like the ancient Silk Road that existed here on Earth thousands of years ago. I can imagine that there will be a new kind of space Silk Road. So this is the status quo. This is the current situation in our space habitats or space maybe shuttles. This is the International Space Station. It is so sophisticated, but so complicated. It is designed mostly by engineers. But you see, this is the kind of architecture that exists today in space. And of course, we have to understand that this is not a very nice environment. It is so frustrating. And it's a narrow space filled with complicated equipments and wires and everything. So imagine not staying like 2 hours in this space, but like 6 months in this space. Of course, it is a very hard experience. So the main umbrella or the main title that we are talking about is called extreme environment. When we talk about extreme environment, that means the lunar environment or building for Mars or even in a zero gravity experience or even on Earth. So that means that we have a problem in gravity. We have a problem in temperature, extreme temperature. we have micrometeorites, we have vacuum, we have cosmic rays, all kind of hazards that can really kill us easily. And we have to think how to save us from this kind of hazards. But also we have challenges like transportation. How can we really transport our equipment? The shortage of a space, of course, because we are designing in a very extreme environment, so we have to save our resources, and that resulted in a very tight spaces. And of course, the main important problem is shortage of resources. So our new architecture has to secure food, oxygen, water, and of course that would lead us to the totally circular economy, or total waste management. So the architectural elements of any space architecture will be a habitat, place that we will live and work, greenhouse, laboratory to make science and to understand the new environment, a power supply. Without power, we can't generate enough heating or even all of our accommodation needs, maintenance, vehicles, and sleep. For the architecture programmatic aspects, we need a place to sleep, to exercise, and physical exercising is important. We need like 2.5 hours in a zero gravity environment per day just to maintain our cardiovascular system, the bone density, name it, all of our muscles mass. This is crucial. This is important for the maintaining and sustaining of the human life. Also entertainment. You can't only rely on having people that would work. We are not machines. We are human beings. And of course, the social gathering, because we are human beings, so we do believe in the social imperative. The one of the secrets of our survival across all of the history, that we are social creatures. Of course, also we need a circulation like staircases, connecting pathways, doors, airlocks, especially if we are planning on designing and building different kind of colonization. Of course, all of this architecture needs infrastructure, like the life support system. Life support system will be spaces dedicated to produce oxygen, to produce water, to produce the food. And of course, we need some windows, and windows was one of the main architectural achievements that we have convinced engineers to add even in the International Space Station. And it was of a great importance. Of course, we also have to consider what is the appropriate light. And light is directly connected for our mental well-being due to the circadian cycle that we are created upon. We can't really function and our conception, perception, and our well-being without thinking about circadian rhythm. The choice of the colors and the materials, all of this also works accordingly. So, talking about space architecture, we have in some scientific papers and some reference books, and some of the NASA scientists classify space architecture into only 3 kind of architecture or classes, I might say. But other reference books and other papers classify space architecture into 4. First one is called the rigid modules. It is the kind of modules that we can call it a pre-integrated module, that it is all built on Earth and then transported into space. Or inflatable modules. Inflatable modules might be a pre-integrated one or a prefabricated one, and it could be also a very lightweight kind of architecture that is pressurized environment once it is deployed into its final location. We have foldable modules, and the most interesting part that I'll be presenting today is called the ISRU. So the ISRU means in situ resource utilization. It is the revolutionary concept that will enable us to build especially on planets. We have 2 kind of space architecture, an orbital one or a planetary one. So if we are thinking about moon, we have to think about using the ISRU, taking the moon regolith, the moon soil, and start 3D printing using the moon soil. So this is the best way and the most feasible way that we can build our first colony over there. What is the difference between designing for moon and designing for Mars? We have 3 phases on moon. First one is survivability. We have to survive. And then sustaining life or sustainability. And after achieving the survivability and the sustainability and ensuring that the new colony or the new habitation will support human life, we can then operate and start thriving instead of surviving. On the Martian phased approach, it's totally different because according to the high distance or the long distance between Earth and Mars, so we are depending on a different strategy. We will be shipping, building robots, maybe working with some kind of an advanced artificial intelligence and human operation, both hybrid one, in an autonomous construction phase. And after building everything, we can move and start operation. So there are two totally different strategies for the two planets. Let's now take a look at some of the presented projects today. By the way, all of the projects are based on existing technologies or near future technologies which succeeded in the experimental phase. So there is no science fiction that will be presented today. It will be all science reality that will occur in just a few years from now. Also, I would like to know that all of the presented projects are internationally awarded and reviewed by space experts and astronauts. So either this kind of architecture that I'm presenting, that may be either used for Moon or even for Earth if we are going to face any kind of existential risks that, like I mentioned earlier. It is all about the community-centered design. So the next colony, it will be dedicated to the whole community, not just individuals, not for 3 or 5 crew members. It will be like a small village. And my personal manifesto in designing for the last 20 years could be summarized in 3 steps. First one, using and borrowing solutions from nature. Nature is the mentor. Nature is the inspiration. Nature offers us a lot of solutions for the most complicated engineering challenges. Number 2, it's about problem-solving strategy, developing solutions by involving the human perspective in all steps of designing. And this is the core of the human-centered design. But I have little bit tweaked or iterated the concept from a human-centered design to a community-centered design. When we are designing with the first approach, the human-centered design, you might get involved with your design team, some of your end users. But for the community, you have to engage a big number of individuals, and the behavioral pattern of people in a society differs from individuals. Third part is documenting those experiencing to pass our traditional system knowledge to the future generations. One of the aspects is the lecture that we are performing today, trying to raise awareness to the new domain, trying to share experiences, trying to educate people. This is the third step in my personal manifesto. We have also to develop some of the essential thinking techniques for architects. If you would like to work for space or think for space, you have to practice. It is exactly like hitting the gym, exercising in the gym 3 days per week. You are gaining the general fitness for all of your body. But also we have some mental exercising to have a general fitness for your thinking method and try to have a better understanding and achieving solutions and designs in much more easier and quicker phase. Sorry for that. So, space settlements. This project was first awarded in Jacques Rogerier Foundation in 2018. Later on, it was published as a scientific poster in United Nations Office for Outer Space Affairs. And it also was awarded and turned into a virtual reality experience in Art Spaceship, VR, an Ukraine-based association. And recently, we are registering it as an NFT to be also shared with the people as a digital asset. So I would like to borrow the quote of Le Corbusier. Le Corbusier told us that, it is always life that is right and the architect who is wrong. So that means that architect should think as nature. We should be thinking as a tree, or putting our shoes in a tree or in a natural habitat form. Also, the Saint Seraphim of Sarov has a much more interesting quote about the biomimicry or borrowing solutions from nature. He told us that drink water from the spring where horses drink. The horse will never drink bad water. Lay your bed where the cat sleeps, as she loves calm place. Eat the fruit that has been touched by a worm. It is always looking for a ripe fruit. Plant the tree where the mole digs, because that is the fertile ground. We might think that we are the most smart creature on earth, but actually we are just part of the system. We are just a tiny part of the whole ecosystem. We have to understand nature and use its help. The horses has the sense to choose the drink, the healthy water and the clean water, that we do not possess the same skill as the horses do. Even the cats, when I raise cats, by the way, and when she chooses a calm place, that means that the place that being chosen by a cat is the most comfortable place that you can really have rest in, and so on. So it's all about emulation, the model system and elements of nature. And I started my journey by the observation and understanding of the ant colonies. Ant colonies here on Earth is one of the most sophisticated kind of colonization. It survives through floods, through disasters, and they create a very healthy and well ventilated kind of spaces even during any kind of disasters like floods or storms. And here is the secret. So by start to digging in and reading more about the engineering of the ant colonies, solutions were offered. The undulating circular pattern that we see with the main shaft is offering us also a solution to a well ventilated place and well organized spaces structures. Also, the oasis or the circular gathering of life form, different various life forms around the source of water. And there is a secret about the circle. The circle is a neutral geometrical shape with one side, an infinite number of axes passing by the center. So the geometrical philosophy of circle is found in nature in variation from the starting from the water droplet to the formation of the different life forms around an oasis. And the human experience, our ancestors living thousands of years ago, we have several experiences here in Middle East that people, to survive the harsh environment of the desert, tended to build inside and in extra subterranean kind of environments, and that enabled them not only to survive but to thrive and build desert colonies and desert civilizations. And we have traces of these kind of habitats and colonies all over the Sahara deserts in the northern Africa. But also our understanding, our conception and perception about the circle. Circle always reflected to us the unity, the social group, the group of friends. Even we use the circle in our daily quotes when we say circle of friends, circle of trust, circle of cooperation, and circular economy even. So the circle also is embedded in our psychology, not only as an answer. So there is a common pattern here, which is the use of the circular formation. And here, Project Lunar Oasis was born. So by gathering all of the previous notions that I have mentioned earlier, I have tried to utilize all of these notions into one engineering solution that can offer us not only physical, well-being physical environment, but also a stabilized psychological and mental place for people to survive and thrive. And by trying to solve it, I have also found answers in our ancestors' culture, the anthropization. Anthropization was the solution that people used to try to transform nature according to their needs. For example, maybe in Indonesia, it is a little bit abundant, and you can find solutions like stepping down the mountain to enable people to farm on the mountain. So the anthropization or the contouring method was also used. I'm trying to simplify, of course, the colonization, but this is a schematic diagram of how I designed the lunar oasis colony. That is the site plan and programmatic study, the first motivator that or the first design generator was finding iced water, frozen water. And by having the frozen water, I start building around the frozen water well. And it is all captured inside a cave, lunar cave, or a lunar lava cave. The lunar lava cave, according to a study from Purdue University that I have found in a paper, scientific paper. So I start building up the schematic or a detailed 3D model of that lunar lava cave that was located here in Philolus crater. And you can find the scale of the lunar lava cave, which is considered to be a very huge scaled in the proportion of Philadelphia city, for example, and that is because the lunar gravity is only 16% of the Earth gravity. So the geological formation of caves enable it to have wider spans, bigger height ceilings, and that also might enable us not only to build one kind of a colony, but a set of colonies all connected through an urban spine connecting all of them. Also, something that I have borrowed from our ancient civilizations from Middle East, which is documenting all of our history. So I start designing a graphic wall mural that indicates our story, starting from 1969 with the first NASA moon landing, and then commercializing or the entering of the private companies into the space industry, privatization, and the emergence of SpaceX, Blue Origin, and different companies, and then start by according to my understanding, that by the year 2030 we'll be having our first colony, or start building our first colony only 6 years after the Artemis program, which is planned to start in 2024. And lastly, hopefully, in 2050, the first human child will be born on Moon. So, according to anthropologists, or the science of the human beings, the human ancestors, and they classify colonization into 3 different kind of phases. The first phase of colonization is just exploring and finding a new land and sticking your flag and then bouncing back to your mother nation. And we have already passed this phase in 1969 when we founded Moon and we made our first landing. The second kind of civilization is some immigrants will be traveling to the new land and staying there temporarily just to explore the resources and trying to transport some of those resources, but they are still connected to the motherland. And I think this will be in 2024 when we start building our first outpost in the Artemis program. But the third kind of colonization, which is the most interesting, and my project is targeting the third kind of colonization, which is building a permanent village or a permanent architecture there for people to start living in. Of course, there is another fourth level of colonization, which is declaring independence, when this kind of colony can reach the self-sufficiency, the whole total self-sufficiency, and they are not in need anymore with the motherland. And usually the fourth kind of colonization is associated with the kind of military conflicts. But anyway, we are designing for peace. We are designing for people to thrive, for our humanity to thrive. So that is my proposal. Some of the engineering challenges was the powering system. So I used multi-diverse kind of powering sources. The first one is a kind of mobile, small-sized reactor, and hopefully by that time we could develop even a fusion reactor, which will offer us much more privileges than the traditional kind of nuclear reactors, the traditional nuclear reactors. But if we even didn't develop at that time the fusion reactor, we have solutions that is borrowed from the nuclear submarines, or even the nuclear icebreakers that might provide energy for at least like 60 years or 70 years. But also I have developed many other sources that I'll be discussing later. Also, I have built up 2 kind of a pre-integrated units that could be an inflatable units, and I call them the safe houses, just in case that any failure or a burst in any of the structures, so they can find a safe house that they can stay, the residents or the new individuals can stay in while repairing the damage in the structure. It should be all, of course, airtight construction. When we think about designing for space, the main problem is not the loads or due to the gravity, but the internal pressure that might burst or might make an opening in any of these walls. The first one in developing, according to my studies in the ant colonization, was understanding the undulation and then interfering with with two patterns of undulating surfaces to resist the internal pressure and create healthy and well ventilated airflow through all of the colonies, until the anthropization method to enable 3D robotics, 3D printing robotics to start building this colony. Also, the colony will take much time to be finished. So it is very important to start by building different sectors from sector A, sector 1, 2, 3, and sector 1 will be a self-sufficient, self-independent unit. So by building unit 1, it will be operating, and then by increasing sector 2, we will be expanding. But that doesn't mean that we will wait until the 8 sectors to be built, but we can start operating from the first sector. And turning now to life support system for our nutrition. I have developed a kind of farming, and the reactor will be used, by the way, also to melt some of the water, and the liquid water will enter to a new filtering plant, which will provide those trees with the essential water and nutrition that will be important from Earth until it is developed and extracted from the lunar regolith later on. We have four different kinds of planting of trees. The first kind is dedicated for nutrition. So we are planting for our food. The second set of planting will be medical kind of herbs and plants for producing some of the medicine that will be essential for the new society. The third kind is the biofuel. It is a kind that could provide you with some traditional fuel to operate. And the last one is dedicated for gadgets like cotton and wood or bamboo, maybe for making some pieces of furniture or for the daily use. And so we are establishing a new kind of a society that might be a little bit self-sufficient and minimizing the need for importing things from Earth. And turning to the construction method, the 3D printing. It is a revolutionary way. I do believe that it will offer new solutions for sophisticated, complicated forms that might reflect high potentials for our new kind of physics inside buildings. So by understanding how it operates, the 3D printing on Earth mainly uses maybe the cement and the water-based kind of paste, but in space it is a totally different experience. We don't have the luxury to use water. Water is a very scarce resource in space. So the solution will be in using another different technique of the 3D printing. And instead of using water and making like this kind of concrete structures, it will be rather like laser sintering and melting the regolith and melting the sand on the moon to start building. So turning again to the ISRU, or the in situ resource utilization. In situ resource utilization is about using the local materials in building your structures. And it is something that we have learned also, by the way, from nature. You can find here different kind of creatures that used that concept thousands and maybe millions of years before our structure and our even existence. So the in situ resource utilization, this is the same method that we'll be using. It is the most feasible method that we can use in building in space. So, and again, nature offered us solutions. And by also digging in the research of what is known as the minimal surfaces. The minimal surfaces for me was a very important and crucial decision. Minimal surface also is something that we have learned out of nature. It is in mathematics, it is the surface that locally minimizes its area. It is using the minimum resources to build whatever you'd like to build. So with the minimal surfaces, I have used the gyroids or the gyroid cube. And again, I found another interesting scientific paper from the MIT about conducting what is known as the gyroid cube, so or the gyroid brick. So instead of using a totally solid brick that will consume a lot of materials and a lot of time and energy and power, you can just use like 5% of the resources used to build the same volume and a whole completely wall with the method of the gyroids or the minimal cubes. And it is, by the way, 6 more times structurally stable than the solid cube. By applying any kind of pressure on the solid cube, internal cracks that is hidden might occur, but on the minimal surfaces, it resists the internal cracks and it contains thermal pockets that will be ideal in the thermal insulation. According to the space architecture manuals, we have extreme temperature outside the structures, so this will offer us multi solutions. Structurally stable, having thermal pockets, it conserves our energy, conserves our resources, so it is ideal. And that was the method that I have concluded in building the colony. And then by covering the outer wall and the inner wall, it will create an airtight construction. Turning to the powering system, as I mentioned earlier, I thought about having a diversity of powering solutions. So the first one was the nuclear reactor that will be in the core to melt the water and to sustain life in the colony. But again, there is another backup plan in case that any kind of failure had occurred in the nuclear reactor. We have solar satellites that will be deployed to gather sun rays or the sun energy and start beaming it in a low wave microwaves beams to the colony, which will be gathered by those antenna, and then it will be another way of powering the colony. And the third power solution is the most interesting one because it is connected to the human behavior. It is about deploying what is known as piezoelectric flooring tiles. The piezoelectric flooring tiles is a kind of technology that, by the way, it is existing and it is sold out in the market right now while we are speaking. By people walking and exercising and maybe even dancing and having fun on the floor, it generates energy. So that means that we have to exercise not only to save your physical well-being, but also for the colony, to keep powering the colony. So by daily exercising and maybe having parties sometimes and having fun and dancing, you can generate energy for the colony. And last thing is having the circular formation was what I called as the clean zone. The clean zone is the internal park. I might say it looks like a park. It will be the clean zone. We have a problem with the lunar regolith due to its very fine granule dust. It enters into the lungs, it enters to the astronaut suits, the EVAs, and it is very hazardous and it is carcinogenic. It might cause cancer, lung cancer. So by building up the colony and by vacuuming and taking out all of the dust from the inner part, it will be a safe zone for astronauts to walk in, to exercise, to having some kind of fun, and to walk in and also to resist the claustrophobic effect of staying in small tight spaces all the time. Now they will be having the privilege to move on and start walking around. But as I have I have a very important quote that I keep saying to my students: the space tourism will start here from Earth. By building a twin colony or a simulator colony or an analog kind of mission, we will be having a good understanding and experimenting. So we have to build up this colony first here on Earth to test it, to understanding, to train the astronauts on, and to also educate people, to raise awareness. And it will also have revenue. It will gain revenue by making what is known as the space tourism. But this will be the first colony that bird. I have been contacted by a government from the Gulf region area to study the Sahara Desert in Dubai to build such a colony. So I had to redesign the whole colony for the new kind of extreme environment, maintaining and saving the same design features, the same shapes, and the same design values, but of course tweaking it a little bit to suit the desert, the Earth desert. So this is the other version or the Earth version of Lunar Oasis, but as I says, it will be Dubai Oasis. And in 2019, I also start developing another third kind of colony. The third colony will be designed totally for the Martian oasis, but this will be a story for another lecture someday, maybe. I'm trying to stick to our theme in the moon camp, but I just wanted to just project a small one slide about the developed version. So it is like a design research, not only one design project. It is a line of design research, and every couple of years I tended to make new findings and turn the projects into scientific papers to share it with the community. So we can see the two colonies, the two twin colonies. The one on the right is designed for the Martian environment and the Martian atmosphere. The one on the left is an airtight, moon doesn't have any kind of atmosphere. So it is designed for the lunar environment and the lunar parameters. The Martian environment, just a very quick glimpse about the design of the Martian colony. It is also deploying or utilizing a different kind of termites pavilion, the one that is superstructural, then not a subterranean kind of colonies like in the lunar colony, but it is a kind that you can find and on Earth here. And by developing the same concept, I start building on Earth and extending from what is a subterranean kind of environment into a superstructure that is going beyond the surface. And that is the lava casting procedures that will be used in both colonies, the lunar one and the Martian one. One design feature was the Tree of Life, this kind of inflatable structure. And by the way, this project also had won in 2017 the first prize in Mars City Design in Los Angeles. And later on, it is developed. And it also, I found solution from nature by reading this fabulous book, The Hidden Life of Trees. And I was amazed to know that trees are societies. We didn't know that trees can communicate with each other. They talk to each other. They have feelings. Trees can feel pain and danger and even joy and happiness. And that research, that findings that we're conducting like for the last 30 years, by many scientists had amazed me. So having an interconnected kind of tree units was a core concept in the new colonization. And from here, I start sketching and developing and in an iterative process to try to reach solutions. And I found solutions also in the piezoelectric energy to generate enough power for the trees to grow. The trees needs photosynthesis. And while we are designing inside a lunar cave, there is a problem. We don't have light enough. So I have to secure light for those trees to thrive. And by the piezoelectric energy, I start generating a kind of energy that will be sufficient for the trees to be lit and for the photosynthesis to be developed. On the Martian environment, there is wind. So wind will be used to move all of these long fins. Those long fins will be generating the enough energy for the tree to thrive, to warm up the tree and to provide it with enough light to thrive. But on the lunar environment, while we don't have any kind of atmosphere, so there is no wind, so by the movement of the people around the tree, it will generate enough energy. So we are moving for the trees to life, and the life of the trees will be essential also for our life. So this kind of balance between our human life and the tree of life will establish a new kind of symbiosis, which was very important also for our behavioral pattern on the new colony. These are just aspects of the tree of life. So I have here just for you presented 3 different awards. One from the Kuala Lumpur Architectural International Festival, one from Paris Jacques Rogeri Foundation, and the third one from Los Angeles Mars City Design. And they were presented also in the United Nations Office of Space Affairs, and I'm still developing it. And also it is registered as an NFT. So by the way, the funny part here that my first prototypes was tested inside my kitchen microwave. So I wanted to know the thermal pattern and the behavior of the geometrical formation of that thermal pattern. So I had to 3D print the first prototype, and this sophisticated geometry was designed to dust off all of the regolith that might be on the surface and ensure that those wires also will be letting all different aspects, all different sides for the tree, just as sun does on earth. So now this is my journey. According in the last 20 years, I have been developing and reading and developing. And as you can find, this it is not just one project and one award. It is a line of research. So I also would like to share with you, is space architecture really a dream? Is a space architecture really a science fiction? According to my claim, no. And all of these technologies that is presented on this slide are technologies that would originally developed for space, but we use today on Earth. I might say confidentially that 45% of the inventions inside your home were originally developed for space architecture. Name it: microwaves, LED, your mobile, even that you're working on, 4G technologies, computer, laptops, all of these technologies, even our clothes, many of the technologies that were developed originally for space are also used on Earth. And the same goes for the coming years when we, as architects, design for space. It is the ultimate kind of sustainability. It is the net zero energy, net zero waste, zero carbon. So by implementing and by using those notions and those concepts on Earth, we will be pushing the human story forward. Till now, thank God, I have reached my 40th award. The last one was in Dubai, designing also another Martian environment that will be presented maybe later on when we decide to make another maybe session for Mars. And for the exhibitions, those are the set of countries that I have either made an exhibition presenting my work or a public lecture that I've been making today. And after this lecture, I'll be adding another one in Indonesia. I'll be having another orange dot there. And the workshops also, I have been so active in the last 20 years. Up till now, 10,000 trainees I have developed, starting from digital technologies, parametric design, building information modeling, and newly, for the last 3 years, also in a space architecture. I have been lucky enough to be adopted and sponsored by all of these prestigious venues like Discovery Channel UK, which presented Tree of Life, Forbes magazine talking about the new kind of NFTs and the space domain, L'Architecture d'aujourd'hui presenting the Lunar Oasis, Arch Daily, NASA Johnson Space Center in 2019 presenting the Martian Oasis, the Tree of Life, and the Lunar Oasis, and in many other places. Talking to people is one of the main goals, making TV interviews, raising awareness, also to try to make people understand the importance of the new domain, and gaining awards also to inspire others, and even talking in TEDx and different venues. Visiting and going and knocking all doors all over the world, going to SpaceX, going to NASA Johnson Space Center, going to Virgin Orbit, and moving around the globe to understand and to learn and to talk. That was during 2017 when I was mentored by NASA engineers to understand and gain more knowledge in the new domain. And I was lucky enough to be also featured on Wired magazine. The same issue was Stephen Hawking. Last thing that I would like to end my presentation is those 3 quotes. First quote on the left, which indicated that the future belongs to those who dare to dream. So we have to dare to dream. We don't have to get freaked out or leave our dreams. And then Eleanor Roosevelt has added another interesting quote, which said that the future belongs to those who believe in the beauty of their dreams. So that means that you have to continue on having your dreams and not let it down. And the third quote by Malcolm X, the future belongs to those who prepare for it today. So that dream shouldn't stay as a dream, but we have to take practical steps to turn this dream someday into reality. By consistency, we will reach the stars, not only by motivation. Thank you all for this nice session and nice presentation. Thank you, Anne, for having this opportunity to connect to all of this fabulous, amazing people all over the world. I do really thank you from the bottom of my heart for dedicating time. I know some of you are waking in the middle of the night to attend this lecture, so I hope that it was up to your expectations. Thank you all so much.
Thank you, Dr. Samer. That was an incredible presentation and amazing work. 40 awards and counting. So, wow. I want to call my co-founder who has joined today as well. Ratri, where are you?
Hi, Anne.
Okay. Is that
Hi,
PD in
Dr.
your
Samer. Thanks so
background?
much for your. Hang on
Thank
a
you
second.
so much.
So she's actually from a property developer family. So, you know, architecture is also, you know, like up her alley.
Thank you so much, Dr. Samer, for joining us today. That was a really insightful presentation. I guess just to, because we've got another 6 minutes to wrap up this session. We've got quite a number of interesting questions, but I wanted to do a couple of things, probably raise a couple of short questions, but I want to take the opportunity as well to introduce Reva Andika, who is from the Indonesian Architecture Association. So the association is also very interested in this kind of studies, a bit different from you know, the typical topics that they're involved with, but I think there are definitely some red threads, you know, in terms of, you know, sustainable designs, as well as green infrastructure, and as well as biomimicry, that lines up with your studies as well. So thank you, Refa, for joining us. We'll hope to have another space architecture session in the future. Perhaps I'll just pick maybe one or two things in our questions list. So the first one is from our form. We've got a lot of students joining us today. Dr. Samer, one of the questions was, do you have to have a special skill or study focus when you want to study about space architecture? And you know, whether or not the knowledge gain in spatial architecture can be implemented on Earth. And I think some of the things you mentioned about before is already currently being used. But yeah, any sort of tips on students that have joined us today?
I can give you some kind of advices. You know, space architecture is the ultimate goal of sustainability. So it is the crossroads also of many disciplines. So you can start by understanding and reading more and trying to train on human-centered design, on the sustainability. So the first one is the human-centered design. Number two is the sustainability. And number three, of course, is the space technology, reading about astronomy, understanding about the circular economy, the zero waste kind of things. So it is all, you know, everything is connected to everything. I would like to remind you with the quote of Da Vinci, who started in maybe hundreds of years ago. This is a very valuable advice. So to wrap things up, the human-centered design is important. Sustainability and sustainable design, this is number two. And this understanding about the space technology, also number three. And last thing, do not forget the slide that I have presented, the design thinking skills, the critical thinking, the kind of horizontal thinking, vertical thinking, inventive kind of thinking, the logical reasoning. You can hitting the gym 3 days per week. You can also train your mind on this kind of exercises. And I know that it's a very limited time, but guys, also just to give you an opportunity, if you'd like to have any questions, you are welcome to connect. I would love to connect to all kind of people. You can send me messages, send me questions, asking for an advice, or even just for saying hello. That would be nice for me.
All right, great. Thank you so much. And perhaps one last question was, what is, this is, hang on a second. What's some of the hardest obstacle that you've been finding in your research today?
Well, the hardest, there's a lot of challenges, I might say, but the most hard thing is working alone. We are yeah, yeah, I see, and can laugh for that, but the working space is a very complicated kind of thing that needs a lot of expertise and a lot of experiences that are working as one mind. So that is the most thing, the hardest challenge that I have faced. But I'm trying to compensate that challenge by having more time. So it took me years to read and understand a little bit about psychology, a little bit about the circadian cycle and new concepts, and every day I dedicate from 2 to 4 hours just for knowledge gaining and for skill training, and trying to apply all of this knowledge into a physical manifestation, which is a project, and trying to test this project in a space expert juried kind of competition, or publishing in a peer-reviewed scientific paper, and taking the feedback. And the negative feedback for me is much more important than the positive feedback. So failure is much more important than winning. Failure is a part of the process to develop, and we have to embrace both. So
Okay, great. Thank you. And lastly, I guess they're far from the Architect Association. Did you wanted to say anything?
well, thank you for showing up today. I would like
Yeah.
to cooperate, and I'm open to all ideas by
ahead.
Antarexa and by Anne. She is a very fabulous. Your guys are making fabulous work, really, and the amazing work that you have done today has enabled people to understand more about space architecture, had enabled me to connect it to people. So I would like to thank you all for that.
We have about 270 million people in Indonesia. So that's why we also want to start introducing space architecture. So today we have Reva Herdiana from, how do you call it, Indonesian Architect Association. Yeah. And how many architects in that association? I have no idea. And a lot of my friends are there as well. But so speaking of working by yourself, so don't worry. We hope to be able to find you troops from
We can collaborate. Yes.
our country here. So Reva, gladly introduce yourself, and just quickly about the association, because we have to move on to Tom's session next.
Yeah. Hi all. So thank you for the inviting me and presentation from Dr. Saman. So from the architecture association, we have about 2,000 members. So
Wow.
for the it's from all Indonesia. So we work for the to provide guidance for the members, establish and implement the professional code of ethic for the architect. So
Well, that's amazing. I do always believe in the power of cooperation and collaboration. And the one of the main secrets that we have survived millions of years ago, not because we are the smartest species on Earth, but because we collaborate as a group, as a society.
Okay, so maybe we keep the questions for later, and we are going to move on to Tom's session now. Tom, are you ready?
Let's see.
Oh, good morning.
Good morning. If you have any difficulties to hear me, I can switch to my 5G connection, because I'm in the mountains now.
Oh, nice. Are you in, what is it, Karlovy? No?
Karlsbad.
Yeah,
That's Karlsbad is like west of Czech Republic, and I'm in the north. But it is kind of similar distance.
Okay. Well, no, we can hear. I think we can hear you clearly. I guess everybody can hear you clearly as well. So, let me remove everybody first, and then you are. Oh, Rachi, do you want to introduce Tom to the audience?
Yeah, I'm sure. Thanks, Thomas, for joining us. So everyone, we've got Thomas here joining as our second speaker. So he is from the architecture company Extend Design Limited, which has experiences across 5 continents, all the way from Los Angeles to Tokyo. So super excited to have him here. He's got a number of team members that have very diverse experience, including from NASA, the ESA, as well as a number of big commercial brands. His research to date focuses mainly on space architecture, sustainable design, as well as green infrastructure. So thanks so much for joining us, Thomas. I can't wait to hear from you today.
Excellent. Thank you very much.
Actually, before we start, can we have a picture first? Hi, Samir. Can we have a picture first? 1, 2, 3. Perfect. Okay, so we'll take more pictures later. But Tom, I've enabled.
I can go somewhere where you have better lights for the picture.
No, we have the virtual background. We need more light on you though. Now you look more human. There you go. Okay, now you're blending with the virtual background before. So
Perfect.
in a room with everybody. Well, Metaverse is it's a hot topic right now. It's yours now. There you go.
Okay, thanks a lot. Sharing the screen now. So, first of all, I can show you what we are doing, and then in the second part, I can show you more about New Prague on the Moon and Lumia rover that we developed. With my wife Veronica, we started our company Extend Design in London and then in Prague as well. And we focus on a number of disciplines ranging from graphic and product design to architecture and even to space architecture. I think there were like tens of millions of products sold that we designed it with Veronica and with our family company. And we had great opportunities to get involved also in mega projects such as Olympic Games in Rio de Janeiro and FIFA Championship in Qatar and missions to the Moon and Mars at NASA and so on. So it was great to be entrepreneur and to have this like flexibility that allows you to jump on a number of different challenges and opportunities that arise on the way. We did a lot of like uncommercial work, such as like research in space architecture, but we also do commercial work because we have to pay our bills when we work on our own. And it was great that we had the opportunity to work even for car companies and several space agencies around the world, fashion brands, and other companies, which basically helps us to be independent. And when I was studying, I was thinking that two biggest challenges that we have in front of us are to stabilize the biosphere on our planet and to move forward, because this sustainable development can allow you to not only to stay on one place, but it can allow you to move forward to other places. In case of mankind, we can start moving to other places in the universe, and it is good not to think only about mankind, but also about other partners in the biosphere, because we are all connected with other elements in our nature, with the plants and other animals and so on. And it is important to think about creating something like nature 2.0, that we are able to somehow contain the biosphere in a way that we can export it to other places in the universe. And it was
Thomas, can you come closer to the mic? Sorry, just so that we can.
Maybe I can try also these headphones.
I think it's that might be a better.
Is it good?
Yes, talk more.
Can you hear me?
Yep, I think it's okay.
Yeah.
Yep.
So after studying architecture on a Czech Technical University, I managed to get into International Space University, where it was amazing mix of people from maybe 50 countries or something like that, and it was fantastic experience to travel around the globe and collaborate with many other professions and many other specialists. And half of the people you can see here worked afterwards in NASA and like other space agencies and Airbus and so on. So that was like very like there was like so many like cool people and nice results coming from that. And we focused, for example, on research in analogs, how to simulate the human space flight on our planet, and we focused on a number of aspects, how to recreate the conditions and how to work on things like regenerative life support system, and that was very helpful for me later that I got into research in these topics for the next 10 years, I would say. For example, with my friend Andrej Doule, we worked on a proposal for a Mars base 10 and other things. And he is now working at NASA Johnson Space Center, and he is one of the architects of Lunar Gateway orbital station. And myself, I was like super happy to get the opportunity to work at NASA JPL and join NASA habitation team and athlete robotics team and some other teams at NASA Ames in San Francisco and Houston and so on. And one of my favorite topics was, for example, working on 3D printing of habitats in the space. And this is actually a project that I started already when I was at the Space University during the studies. And thanks to this project, I actually got to JPL. And my friend, Rich Rieber, he was in the class of International Space University. He was actually already from JPL, and he told me about new technology of microwave sintering and the robotic systems that can enable you to 3D print buildings. But they had no architecture proposals how the buildings built by this technology can look like. So we basically did like a first proposal using this 3D printing technology being developed at NASA JPL, and later when it was shown at the International Aeronautical Congress, we have seen that we are actually two teams in parallel, and Isa was also working on the same topic with architects, Norman Foster architects from London. And you can see that many newer 3D printed habitats are using these technologies that we started working with in the beginning. And you can see that even, for example, Chinese space station proposal, it was like kind of similar to our concepts that we designed it for NASA. For example, at the United Nations conference in Vienna, they wanted to show how Moon Village could look like, and they didn't have illustration that would be suitable because, for example, ESA was showing one 3D printed module everywhere, and they were saying this is our Moon Village, and we were saying, everybody was saying this is not village, it's just one module. And we were asked to design like a vision of Moon Village that would integrate efforts of many countries, global collaboration. And this is how we started working on proposals for the meeting in Vienna, for the United Nations. And then every year we are basically working on a new concept, how the global Moon Village can look like. So we are now preparing another one for international conferences in March. And at NASA, I was also helping with other projects such as Deep Space Habitat Demonstration Unit, and it was cool to see the simulations in Arizona desert, for example, and so how people integrate architecture together with buildings and robots, and how they test it together. It was cool to see the logo that I designed it for the project everywhere, even on like documentaries and stuff like that. And for example, with Buzz Aldrin, who already got to the moon, I collaborated at JPL on a mission to the Mars, and he got like several strategies. He invented several strategies how to make sustainable settlement on the Mars and how to make sustainable logistics thanks to a cycler spacecraft. So I was designing. I have put together a team of around 10 people, and with some like leading experts on artificial gravity and solar electric propulsion and stuff like that. And yeah, we did a number of concepts how basically these spacecraft with artificial gravity, for example, Mars mission and asteroid mission can look like. And we worked on a number of proposals also for Mars, 3D printing, and so on. And my problem is that I'm too tall to be comfortable in a current spacecraft, and I hate like small spaces. And that's how I got into designing like inflatable, deployable modules and 3D printed modules and so on, because it enables you to live in a much bigger spaces than you can fit into the top of the rocket. And with my friend, who is from British billionaire, one famous British billionaire family, we started. So we worked on several startups, and one of them being is ST in Switzerland, which is focusing on life support technologies and biotechnologies, and we were designing proposals how to make like a simulation of space station with a closed loop, and we have taken part of a former Coca-Cola factory in Lausanne in Switzerland, and we turned it into laboratories for space research. And in Lausanne, we organized first ESA called Habitat Forum to bring together specialists on this topic from everywhere around Europe, and discuss how we can make greenhouses on Moon and Mars, how we can clean the water and do all these things that you need when you are closing the loop inside. And after this conference, it was very cool that we were invited with Veronica to experiment in Italy, north of Italy, where you can see, for example, greenhouses underwater, which is like amazing experience, and you feel like in some action movie when you are like driving there on like electric scooters underwater, and then you see this like underwater futuristic colony of greenhouses that were built for Expo in Milan. It's like 8 meters deep, and they test 5 different species of plants, and you can see how they like recycle the water. You know, you get like fresh water thanks to condensing of the water on the bubbles from inside. You know, and there is a machine control in a beach hut, which is like full of computer screens. You know, and
we can totally do that in Bali. Oh my God, that's so doable.
No, that would be fantastic.
That was so doable. Yeah. Okay.
That would be amazing. We should do it. I will connect you with the president of Ocean Beach.
That would be amazing. Okay, great.
And they also develop these like high-tech technologies for like communication underwater and all kinds of like scuba technology systems. And for example, with the greenhouses, which is like my really favorite topic, we got opportunity to become a part of a European-wide project called Eden ISS, which is focused on developing technologies to grow plants in the space. And the technology demonstrator was sent to Antarctic to grow the food for the members of German Niemeyer station in Antarctic. And our friend Paul Zabel, he spent there like several months, and when he returned, he was celebrated like astronaut. He survived harsh conditions, in Antarctic winter and so on.
We
And,
will
it is
also
growing more
have
food than,
space farming. We will also have
Yeah.
space farming sessions. So this will also be good.
Yeah. So maybe we can connect also with German space agency DLR, because they are the leaders of this Eden project, and they have mission control for greenhouses in Bremen, where we went. And this was my task. I was working on new generation of like a deployable space greenhouse that would automatically expand, and while expansion, it would automatically deploy internal structures as well. You can see on internet many space greenhouses that look very nice on the picture, but many of them would be really a headache to build in space, because it would involve like incredible amount of human work or robotic work and so on. Our task was actually to make a greenhouse that can deploy automatically just by inflating it, and that can be a practical solution, especially when you are in space and you don't want the astronaut just to spend like half year just by constructing the greenhouse when they can do more important tasks around. And this is the interior, and you can see also after interior, you can see also when we zoom out how it can look like from outside. And basically, it would be protected from outside by 3D printed and assembled structures that are for radiation and thermal shielding. And this is how it can be connected as a part of the Mars base. And we are using these also as part of the Moon base as well. This is another European Union project that I worked on with partners Thales Alenia in Turin, in Italy. And we developed a water cleaning system for space stations, and also it has a microbacterial detector, which is important. So you can manage the microbacterial contamination directly in the space station. And when you have like 21 years old space station, you can have all kinds of like bacteria in various corners of the spacecraft, and it is good to have hardware that can detect it. It was tested in Tuscany in caves, and it was compared with like other technologies, and it works. And I loved going to Brussels to like European Union Tower for research. This is like research executive agency, and we had presentations there to other people from Europe and so on. And we organized workshop on several topics that were focused on life support systems. We did like many other projects, also like with satellite communications and so on, that I could maybe show you later if you follow our social media, and if we get connected, get in touch with you guys, and definitely you can see more new projects coming soon. Regarding the terrestrial project, I think on the boundary of terrestrial and space projects are things like mission controls that we were, for example, working on. And this was developed for Airbus with a company AWR Lloyd in Thailand. And it was fun because they focus on all kinds of like advanced interfaces and so on. And this one was for a pharmaceutical company during the COVID crisis. and always when you think about like projects that are in the future, you start thinking about how even like your neighborhood can change. And I spent 17 years since my studies to design all kinds of visions of Prague, how it can change, future visions of Prague, and it became a most visited exhibition of National Gallery in that year when we started. And since then we are making new visions, how we can how we imagine some parts of the city, how they will change. And for example, I was born and raised in this neighborhood, and I wanted to have Hyperloop station in south of Prague. So this cool technology would basically connect many regions of Europe into one agglomeration, and this would be a great communication point where you can connect 5 modes of transport, including the drone taxi and so on. I was in Dubai Expo recently, and I was sitting in the seats of a future Hyperloop cabin. So that is coming very soon, I hope. And you can see that some of the visions of Prague that we designed it were put on like covers of magazine, and that is written like wild visions of young creators, you know. And then a few years later, this was built for 60 million euro. And it just started as a vision on an exhibition, and then by incredible coincidences, the municipality started constructing the bridge at this very place, and they got inspired by our concept, and the final result looks quite similar. So when I go there, for me this is like Fata Morgana, because I was imagining how bridge like this would be nice there, and suddenly it is there. And this is what I call a virtual boomerang, because you throw your idea somewhere and it can return to you in a little bit different form, from different angle. It doesn't always have to look the same, but in many cases this is amazing about like power of imagination and power of architects that you can inspire other people. And when you make visualization or with virtual reality and you present it to other people, it can actually become reality quite soon. And I was invited to London by AECOM, which is the largest engineering company in the world. It was largest architectural company in the world at that moment, to help them with futuristic buildings for Qatar FIFA championship and for Olympic Games. And with my wife, we moved to London in 5 days to start working on that. And I was working, for example, on like aquatic center and so on. And this was my favorite project. I was working on a futuristic visitor center for Doha in Qatar, and it would be suspended in like 50 meters above the highway crossing and connected by cable car with the base station. And inside it would be experience like from a movie when you are there in the media center. This is, for example, the toilets that are more like on the space station or Airbus aircraft or something like that. And this is how it looked when they started constructing it. And now it became like a monument, even on stamps, and they call it Arch of Qatar, and it's now like the symbol of modern Qatar. But it's pity that they still didn't build the visitor center. That was my baby. That I was like looking forward to build it. Even though I was also modeling the arch with my other friends at AECOM, my most work was on the visitor center, which was not built yet. And since the Qatar and the Doha authorities left modern architecture and like futuristic designs and so on, we were invited to help with like public spaces all around Qatar and building new infrastructure and so on. So I had like a model of the whole city of Doha, of the capital of Qatar, in my computer, and I was adding there. I was designing new elements like smart city systems and new bridges and shopping malls and waterfront and all kinds of buildings. And for example, for Yas Island in Abu Dhabi, I was designing new transport system that could be also by using cable car, because you are crossing the water features, water canals and so on. That was a lot of fun, a lot of fun. And with my friend, we also wanted to improve environment in the cities around the world. And one of them is one of the strategies is to introduce more greenery. And we started in a company and initiative called Living Green City. And we managed to invest into biotecture. We bought part of the biotecture company, and which is like a leading company constructing living walls. So they are making the biggest living walls in Europe. And with them, we started thinking how we can make London greener and other cities by making like all kinds of buildings with green facades and so on. And for example, this was development of my friend. He has bought building close to Oxford Street. We have put a green facade on it. I have put there like visualization with like a green facade. And I was showing that in the future there will be like more trees and maybe living walls also on opposite buildings and so on. And it was very cool that after we built this first living wall, when I was there, the opposite buildings also started putting living walls there. Smaller than this, but suddenly the nature, once you seed it somewhere, it starts popping out. You know, it's fantastic that you can change the climate in the street, and definitely it can continue to more places like this. And this became like iconic project in London, which is it's a facade of a Regal House next to Covent Garden Station, which is now on many Instagram photos. And some other are around, like other underground stations and so on. That's great to see some of them. And for example, here, this is a spin-off of our research in 3D printing in space. We have built a first Czech 3D printed house called Probok. And we got robots from ABB, and we started building like a small house that could be like a cabin. And after a while, it was printed. It could be printed in one day, basically. So in Prague, you wait for building permission 1 year, and then you can build it in 1 day. So that's like incredible how like some of the processes of the state are from like 19th century, and now you have like 21st century technology to build, and it's like incredible how these things are like, some of the things are outdated. You know, it was placed next to National Theatre and next to between National Theatre and Prague Castle on a small island in the river, because we couldn't get a building permit in Prague for a thing like this at the moment. So we have put it on a floating platform, and it became like super popular with like many visitors and so on. And it was sponsored by the major bank. So it was published, and it was published all around the world. So yeah, it was necessary to put a green roof and green facade on it as well. I was like, happy to involve it in the design. It was designed mostly by my friend who is a sculptor, so it looks more like from Lord of the Rings or something like that than like a spaceship. But I was helping to model in a 3D parts of. I was making like some versions of the 3D modeling and so on, putting there the green elements and so on. And for example, we love designing housing and integrating the buildings with the nature. This is a newly constructed project in Prague that is sitting above the stream in very nice nature. And I love inspiration such as like motor, such as boats and Tesla cars and so on. So that was everything included in this recent project. And
Just
see
a
the content.
friendly reminder, it's 30
Mhm.
minutes to go. Maybe you want to start shifting to Luniak.
Yeah. So this is by very soon ending.
Okay.
Yeah, we are integrating nature also in offices, and we are also working with many architects with many virtual reality technology, which is very helpful for architects, and it helps us especially to present it to clients. But not only that, we try to use virtual reality in the whole process, from sketching of the idea and developing the layout of the building to the final presentation to clients. It's a really powerful tool. And that brings us to our second part. Can you see it? So we started working on future visions of Prague in 2005 when I was on university in Prague, and I have put together a team of 40 people, mostly my friends from the studies, and this was my individual project on the university. I submitted it as my semester project, and it never finished. I'm already 17 years of working on how the Prague will look like in the future, and Prague for me is a really inspiring city, I would say, because there is a legend that says that the city was actually invented by Queen Libuše during the time of plague pandemic, when there was like an epidemic of some bad disease, and there was like political chaos, and the people came to Queen, and they were asking her like, what should we do, and how can we solve this situation? And she said like, we should start making a new capital that will unite all our nation. In the legend, they say like she was saying like, I see a large city whose fame will touch the stars, and it's very cool that Prague became one of the most popular cities in many rankings. You can see that it's like in top 10 life and so on. It was like invented 1,000 years ago, and they practice on a new continent. I was after seriously, we can start seriously discussing how thanks to
We're losing you. The connection isn't so good. Hi, Thomas. Oh, I think he got disconnected. Samer, are you there?
Yes, I'm there.
Maybe you can take over until he returns.
He's back. Yeah. Welcome back, Tom.
Okay. Yep, I think because he is at the mountain, he's having a network connection issue.
Okay. So thanks to Apollo
okay.
program. This
All
is
right.
working again. Yeah.
Yep. Okay. Okay, he's back.
Mm-hmm. Yeah, I would say that Moon is now new continent of our planet. it is really like very similar to situation when Columbus went to discover America, and then after a while, it became like a space where the humanity or where I mean like where Europeans could expand and start building their new things. In this case, it was waiting 50 years, 60 years after Apollo program until we developed new transport systems. But all these things are now happening in real time, and we can look forward to many new space companies that are building orbital infrastructure and logistic systems and so on. And now you can see like many new companies in America and worldwide that are preparing new space modules, and this industry will start booming very soon. Especially thanks to space tourism, I think that's like one of the biggest sources of income in the near future for these human space flight missions. It can become a big thing. And NASA with ESA and other international partners is constructing orbital station gateway. Our friends from Vienna, they are working on architecture for iHub in ESA part. Andrei Doule, that I was mentioning, the friend from studies, he is working on architecture of the Halo module in the middle. And with company Solstar from US, I'm also working on one component for the Halo module. So stay tuned, and I will later. I will be able to share more with you later when it is not secret. And in the beginning, we will need like lunar landers and other systems to enable you to do like spacewalks and do like first initial missions to explore the area and so on. And soon after that, we will start building the moon villages and modules that will enable sustainable presence on the moon. And later, it will become even cities. So this is really happening now. Every week, you can see some news from SpaceX and so on. And this is like super exciting time to be in this field. And myself, I was working on a number of proposals for the global moon village. And based on that, I wanted to show people in Czech Republic that there is a really promising future in front of us if we will be able to go on the path of sustainable development. In that case, we could start building even like things like New Prague on the moon. And we wanted to show that this is not impossible if we will be successful and if everything will go right. And we wanted to show that we can even take some features from our current city, such as like Wenceslav Square, which would be like the core of a new settlement. And we have like on horizon of Prague, there is a TV tower, which looks exactly like a rocket at the launch pad on some spaceport. And that was designed by my professor at the university, professor of architecture, Aulický, and he brought me to the top of this rocket. and this place is called Žižkov, so the launch pads are also called Žižkov, and it is connected by Magistrála, which is like the artery road in the center of Prague. And you can see that many things could be like translated from current city into the future, and it doesn't have to look like the city on Earth at all. And we partnered with a new virtual reality laboratory called Virtuplex, which is largest in Europe, and it's unique also worldwide. And our friends, they basically took industry hall, and they developed a VR system that enables you to share virtual reality with other people. And you can walk freely on a space 600 square meters that totally gives you like different, more immersive experience than if you are just sitting on the sofa with VR glasses. And all this was connected with my interview for Television Nova, because they were asking me like how we will live on the moon, and what we will drive there. And I was saying like, Czech people love cars, and we are like major car producer. And I was saying like we should think about Czech cars in the space because we are now like becoming more successful with like space manufacturing as well, and we produce the cars, and maybe these two things can connect in the future. So now, for example, we are producing a successful electric SUV called ENIAC, and we can show that one day Czech electric cars could even drive in space. I was helping Škoda car manufacturer with architecture for a launch of SUV called Karok in the past, and also architecture for other things, such as concepts of public space in the factory. And they invited me as a speaker to Škoda Meets Space conference to find a synergy between like space technologies and automotive technologies and so on. And the television asked me like, can we show how you are like designing the Czech car for the moon? And I said, okay, no problem. And for me, it was like a big motivation. It was like biggest driver for me, because then I had to do it. And the television came to our house, and they were filming me how I'm sketching and designing it in virtual reality, and modeling the rover and so on. And it was very cool that at the same time there was a Czech Space Week coming, and the Ministry of Industry, they loved the idea that we could show Czech space car and Czech space colony as a part of Czech Space Week, and it all connected as a kickoff event of Czech Space Week. And we designed it vision of the city on the moon, from connected modules which are 3D printed, inflatable, or pre-integrated in factories. And it was connected with solar farm and a nuclear reactor. Now we are meeting next week with nuclear engineering facility near Prague with the directors there, because they are working on a small scale reactors that can be used to power a city, for example, or a moon colony. And we will be thinking how to show how this could be implemented in a future space colony. And I'm meeting with the directors that are building and designing nuclear power plants all around the planet, because they are successful in this, and they are hired by American companies and Russian companies to design the nuclear power plants for them, and then it is built, for example, in Turkey. And in case of the rover, you can see that it consists of more parts. We took a platform from NASA. NASA developed a lunar rover called LER and also MMSEV. And I was myself in Houston where I saw how they are developing cabin for the MMSEV. And I was thinking, okay, let's use the standardized element, the platform. It's the same as, for example, Škoda makes it as a part of Volkswagen Group, because they take the platform from Volkswagen with the batteries, and so on, and they built like around it. So we took the MMSEV platform and put like new wheels and suspension and so on, and we designed it our own cabin. In our case, this is more focused on space tourism, and it is inspired by Czech cars. And Czech cars are usually for family or for people with spacious cargo, and it's usually very practical. In our case, we made like big panoramic windows, which would be possible thanks to technology called ALON, which is transparent aluminum, and it is more resistant to micrometeorites. Here you can see a hatch that enables you to connect to space modules around you. You can see here front window that enables you to watch the terrain, and here are stereoscopic cameras, so you can see everything in virtual reality with the headset. And you can see it stereoscopically, and you can it can work autonomously, or you can control it remotely thanks to stereoscopic system, or it can be driven by the pilot. Here you can see the back part where it could be attachment of space suits. So you can climb through the back of the space suit into it, and you prevent getting lunar dust inside the cabin. And here you can see radiators, solar arrays that could be deployed when you are standing still or slowly driving, and of course, like communication systems. And it was great that we did several events. It was not possible to gather too many people because of COVID and also limitations of the space. In the simulation, that could be up to 9 people in parallel. And it is great that people can share the space together, and they see each other in space suits. You can see your hands, for example, in front of you, and you see other people in the space suits, and you can talk to people, and it becomes like a social event. You are not alone in like a simulation, and people really enjoyed it. And thanks to journalists that were enjoying it, it was great that it was published everywhere around Czech Republic and further. Here you can see how it looks in the simulation. You are basically wearing a backpack with a strong laptop, and this is a Reverb Generation 2 from Hewlett-Packard. This headset has also like additional sensors to track your hands, so you can see your hands with astronaut glass in front of you. And nobody expected that we will get too many news and to like covers of the newspapers, and and it was really a surprise after 1 month when I opened Google. You start Google News and you type Luniac, and suddenly you see that it was mentioned in India, and it was in America, China, basically like all around the planet was mentioning it. And it was maybe thanks to combination of several elements, because many of the magazines are actually focused on cars, and myself, I also love reading about electric cars and so on. And it was also about design and architecture, so it was in journals like Design Boom or Design Mag, and it's also about business, because we try to show what is the path to get to building space colony. And the good prosperous economy is one of the key elements to it. You can see like Forbes magazines and so on that were like on our table in our house, piling up before the Christmas. And it was funny to see headlines like this when I can't read any report except Luniac, or it was all Chinese, and there was just like a picture of that of the rover. And it's great that the interest in space is now like getting higher and higher in Czech Republic and worldwide. You can see kids, wearing hoodies with like NASA logos and so on. And it is really important that we are not designing it for ourselves. I'm more like designing visions like this for like our kids, because young people will be the people that will build it soon, I hope. And it was very symbolic that we were invited to Prague Castle, which was a product of the prophecy, of the vision of Queen Le Boucher, basically. according to the legend. And on Prague Castle, I got opportunity to present how our society can move forward and how we can continue building new Pragues in the space as well. So that it was an amazing moment to be in a place that is a product of the vision and to present your own new vision there. And all these things, when I was thinking about it, all these things are a little bit science fiction, but it's not impossible. And I think that New Prague on the moon is just like good to inspire like people in Czech Republic, but I think about it as a global moon village. And if we will be successful, we would be happy to, for example, participate on space exploration on the moon, and maybe to help building some of the modules or some like robotic elements or something like this. And it would be definitely part of like a wider collaboration between more nations. And I think from our perspective of people in Prague, I think it's necessary to, if you would like to get closer to these things, it's necessary to stabilize the environment on Earth and start building, for example, more sustainably. I was asked recently in the interview, like how I imagine like houses of the future, and I said, like, I think we should start building everything from the wood now, because that's the way how you can extract tons of CO2 from the atmosphere and store it in the buildings, instead of like producing more and more tons of CO2 by using the concrete. It's about like agriculture, because the biggest potential how to store CO2 has the soil, and it is even much more than the atmosphere itself, even more than the whole ocean. The soil on the continents are the biggest potential sink of CO2, and the agriculture is basically seasonal. Producing seasonal changes of CO2 in the atmosphere. And you can see that if you, for example, stop using like toxic substances to kill all the microbacteria in the soil, you can store more CO2 in the soil if you do it as a regenerative farming instead of this like current farming methods that are basically killing everything except one plant, you know. And all these things are necessary if we would like to go forward, and space colonies can be done only thanks to like really going the path of sustainable development. For example, we need to motivate more our society. It's about like it's also part of like generation exchange, as I can see, because young people are super enthusiastic, super excited about it, and old people are skeptical and negative. so I think this will like change by the time a little bit, and also it can change a lot when people see success of SpaceX, you know, flying with new Starship, for example. I hope fingers crossed that it will work, and then even like bigger investors will jump on board. When I was in Dubai, my friend Brent Sherwood, who is vice president of Blue Origin, I went to lunch with him, and he said he can't tell me what he will be announcing. When I asked him what he's working on, he said like otherwise it will not be announcement on Tuesday. And then on Tuesday he said they are now building a new huge space station with Jeff Bezos and with Blue Origin. And one day later, I even saw in the elevator on the TV screen in our building in Dubai Marina that UAE government is speaking with Blue Origin, with my friend Brent Sherwood. They are speaking how to make a space tourism program on the orbital reef space station. So now it becomes really, I think, that becomes a viable business, and that's important. And there is a problem with Czech economy now, because we have a lot of investment from abroad, but it means that all the profits are again flowing away from us to abroad. So I was saying like we need to we need to support like Czech companies focused on exporting, Otherwise, we will never have enough money to do some significant change and afford the space program. And of course, like geopolitical stability and global cooperation is important. Russia is, gathering the army next to Ukraine, and everybody can see that they could attack East Europe, and there could be like huge problems behind the door. So there is like things like this can really like have big impact on plans to make like space settlements. But if we will be successful, we can look forward even to things like new Prague on the map in the future. So thank you for joining us. And myself, I don't enjoy too much like speaking through the wall because I can't see you now. I prefer like meeting people in person and interacting with them and brainstorming what we can do. But this is amazing that at least we can connect like this, and you can see what we are trying to do. And I would love you guys if you could connect with us, with me, on LinkedIn, Facebook, Instagram, anywhere. And it would be great to start some discussion. How we can collaborate on building things in space. I would also direct you to spacearchitect.org, which is a website that we are doing with our colleagues from NASA and universities and so on. And it's promoting the field of space architecture. There is a lot of resources. If you are interested in the field, you can find links to universities, to archives of research and all these things. Okay, so I think that's everything that I wanted to share with you guys. And I hope I will meet at least some of you later on social media, and we can continue collaboration and conversation.
Thank you, Thomas. That was splendid, and we cannot wait to bring Lunia to Indonesia. We're in the talks we're organizing, so we'll have a catch-up session about that. Calling Ratri now and Samer to join again the session. And also Ernest, if you're there. And Rifa from the Architect Association. If you have any, maybe you can exit your PowerPoint, Thomas.
Mm-hmm.
Yep. There you go. I don't know where's Ernest, but feel free to have the conversation, Ratri and Samer.
Well, thank you, Thomas. It was very impressive. Really, I enjoyed the progress of your work, and having two aspects: the scientific aspect and the human one, the journey, of course, of success. It was so inspiring. I have just a small inquiry that I would like really to ask you. I do believe that the next generation technology will be about the metaverse and the virtual reality. But, I have also been facing some challenges that I would like to bring that to discussion. How can we solve some of the issues like the zero gravity in a metaverse maybe, or in a simulation, virtual reality simulation? Did you think with your team about solutions for developing this challenge? How can people experience zero gravity while they are in the VR? I know it's a challenge, and there is a lot of discussion and debate actually all over the world about these issues. I do believe virtual reality will offer good solutions for training and simulation and for preparing people to experience the new thing. But the main problem with us was always the zero gravity thing.
I have the answer for that. There is a company in the US. It's called Space VR, I think. I can't remember now. I know Ryan is the CEO. So they are combining VR with float tanks, a float spa. So
you mean it's like an underwater experience?
No, float spa. Float is do you know what a float spa is? Floating.
Yeah, floating water, you mean?
Yeah, the float. It's like float spa, usually for like meditation and stuff. But you go inside this. With float. You combine it, and then you use the VR headset, and then they will show you, of course, pictures. Like virtual reality of galaxies, and then now they're gonna also have their own satellite.
It's a very
So
smart solution.
yeah, and they're
It's
gonna
so
have that
relaxing.
satellite. They're gonna have their own satellite, and for those who subscribe, they are going to try, as much as real-time satellite images of the Earth or deep space as possible. I don't know what you can see in deep space. It'll be way too scientific, but they're trying to do that, and they have set up in New York, San Francisco. They're trying to set it up and to work together with Float Spa all around the world. Actually, they're looking for one in London. But yeah, so that's kind of solving the zero gravity experience between the virtual reality experience and the physical sensation of floating in space.
Lockheed Martin in United States also that developed something, but instead of floating in water, it's like air cushions, or making something like a zero gravity experience with using high pressure air pumps from below, of course. So they are developing something, like that. So using airflow or water flow is a very smart, and I think it's a relaxing one. But it's also would fall into the category of tourism, some kind of a space tourism, maybe having a new user experience. Yeah, very very smart solution, I think.
Yeah, I love myself simulating weightlessness while scuba diving. So I think that's like a good astronaut training, and all astronauts are basically scuba divers as well. I was at a neutral buoyancy laboratory in Houston at NASA, and they have this like biggest world's biggest swimming pool with the whole space station submerged in the water, and that's basically how you simulate weightlessness.
Yeah, water has
in
been
virtual
used
reality.
for that.
That's very good. And I think with virtual reality, I tried some simulations that are in 0G, and I kind of was able to forget about the gravity for the moment. So I think that was immersive enough to focus on the movement in 3D, and you can simulate it definitely to some extent also with normal VR devices. But for example, in case of the moon, I think that was very good to simulate it in Virtuplex, because I almost felt lower gravity after spending there like half an hour or like few minutes, because you are running around, and you can jump a little bit, and you can feel lighter, in the simulation when you know that there is lower gravity, because it was so convincing that you really feel like that, even like with the aspect of lower gravity. I think it would be interesting to make a simulation for interior, and it would be good that in the interior it would be even better to get a good sense of the scale of the rooms, and finding for example good solutions for various tasks and so on. I think for designing interiors for the moon base, for example, it would be fantastic too.
Yeah. Did you consider registering or saving your work as NFT, non-fungible tokens?
Yeah, actually, this week we were thinking about it, because the Škoda car marketing department came to us, and they were saying like, we would like to start doing NFTs, and I was saying like, okay, what is your idea about where you would like to sell it, or what do you want to do? And they said, we know nothing about it, but NFTs are cool, so we have to find like various options how to do it,
Yeah.
So this is
Same
like
for me,
typical.
I do believe that will be the next wealth. It will be the next real kind of real estate. So you can build up building and think and new experiences. Yeah, I started by registering some of my Lunar Oasis NFT, but the real thing is I'm planning to give a complete kind of user experience, something like a movement inside the space, not just an image or a video, and having something like an executable file of VR to enable people to wander and to walk around it. So till I develop this kind of technology, I'm trying to work maybe on Unity and start also by experimenting on Unreal Engine, but I didn't. It's a work in progress. I mean, but I started by transferring it the images and the videos into NFT. But I think in the next few years that will be the trend. You know, it will be the new thing.
I think that's very promising. That's really like a future of licensing the artwork. And in the case of virtual reality, that's a question. I think that what the car company was saying that they actually like digital collectible connected with like physical assets. So, for example, you buy some let's say animation, which is like NFT animation, and at the same time, for example, you get by post 3D printed model of the lunar rover.
So and you have like virtual and physical.
You have both, yeah, and or you can, for example, make like high resolution data for printing, you know, and then you can also get like physical nice picture on the wall or something like this. I like the idea, as you say, that you make like a standalone virtual reality package which you can shape. That's nice. But when you have like open metaverse, you know, in the network, you can really sell part of the metaverse landscape or some, you know, assets like buildings and so on, and that's revolutionary now. So now we were just like thinking about the design, and maybe this year we can think how to implement this like social aspect and the financial aspect. Do you know about some metaverses that are focused on space? Because I have seen like a tropical island, or you know.
I know some platforms that is in developing for the metaverse thing, but you can choose either you'd like to work for space or other. There is a platform called Mona Metaverse. They were running a competition just a couple of weeks ago. I didn't have time really to enter this competition, but it was so interesting to start this new kind of profession. But I think they will give you like 3 different kind of files that you can open as a market and exhibiting your work and connecting it to a digital wallet like MetaMask or Binance, for example. And you can up to 3 free files. You can upload it on their platform. They're working with Unity mainly. So you can start by that. Mona Metaverse.
Yeah, I will check it out.
Renaissance, yeah.
Yeah, we actually developed this Prague on Moon in Unity. Sometimes I prefer Unreal Engine because of a very nice visual quality, but Unity has it's like very powerful tool if you want to develop applications with that. So far it was all developed in Unity.
Yeah, so thank you guys. I think I have an important thing to catch up with. So Tom, let's talk also again later about this kind of thing. I'd like to share with you.
Yeah, sounds great.
Mona Metaverse, and I was really had a very pleasurable experience today, and seeing your work, it's amazing. Keep on.
Oh, thanks a lot. I love your work as well. Okay, thank you very much.
Yeah, and thank you, Anne, for that kind of experience that you have provided all of us today. This energy that we all can feel, and you are an amazing person. Thank you so much.
No, thank you. See you later. See you soon. Thank you very much. Yeah, maybe Anna, I don't hear your sound. Maybe you are saying something.
Okay, hello. Sorry.
Yeah, no.
Okay. I think just before we leave, actually we have just some time for a few questions, I guess. from the form.
Yeah, definitely.
Ratri want to answer that question, and maybe everyone, if you can, hang on, before everyone turn on the camera, let's take a picture again, 4 of us. 1, 2, 3. Great. Okay, now everyone, we want your
Yeah, I see more
cameras
faces now.
on.
Hello, guys.
Yes.
Turn
Can
on
we
cameras.
turn on your camera, and we want to see all of you. Please join us.
That's great to see you.
Hang on, I just have to remove everybody's spotlight, and if you all, oh, Rachi, can you share the, what's the name?
Yeah, I will be sharing the form, guys, for everyone that needs the certificate of attendance in the chat box. So thanks so much for sticking around so far.
Whoa, why am I the only one here? Why am I the only one here? My spotlight was running one. Okay, this is weird. How do I do this?
Yeah, you need to switch to gallery view. Gallery view, maybe.
I need to remove everybody's spotlight. How do I do that? Oh, hi, Ernest. Thanks for joining again.
Hi.
Okay. I can't do this. What's happening? Ernest, can you help?
Click on switch to gallery view.
Continue. Remove spotlight. What is going on?
Now remove spotlight and then go to switch to
You need to
gallery view.
remove the spotlight.
I am, but then like I have to remove everybody's one by one. Which is crazy. Hang on.
I think you can switch to gallery mode, and then you will see every face.
Okay, hang on. That's true. My God. My brain is not working today. So sorry. Okay. Hello. Did you share it on the chat box for the sign up form?
Yeah, I did.
Okay, great. Can we take a picture? 1. Valen. I cannot see your face, Valen. And Jovanka Tatiana. There you go. Thank you. Valen, we cannot see your face. Okay, 1, 2, 3. Next. Ta-da.
It looks cool how you distributed the backgrounds. It looks very professional.
Putri, Dwi, Amanda, I can see your bedroom. I cannot see you. 1, 2, 3. That's nice. So, okay, so that's cool. Is there anybody who wants to say anything to Samir and Thomas? I think Elif had her hand up. Is she still here? I know Elif is a student of yours.
Yeah,
I
she
think.
is. She's an amazing person as well.
Where is she?
Thank
Is
you.
she still here?
I'm here.
Where are you? Where are you? I can't
Happy.
see you.
My camera is off, sorry.
Oh, okay. Okay. Hi. Thank you for joining, Elif.
Yeah.
Unfortunately, we cannot see you, but there you go. I think we had. Hope you all enjoyed today.
Yeah, it was so great. And always Dr. Sommer, so amazing. And the presentation of Tom, so amazing and inspiring. And I hope I'm following you guys and I will be next to you so soon. Yeah, thank you so much for all the information.
Thank you.
I know
Elif.
that you are very passionate about space architecture, and now you're trying to be, like on the path to being a space architect, especially by following Samara and Tom. But like, as for yourself, for peer-to-peer, for other students here, they're still trying to understand and learn and trying to pursue a career in it. Do you have any advice or any suggestions as a peer-to-peer suggestions regarding the world of space architecture that is currently developing right now?
Actually, I think that
can you talk louder, please?
There is no available school for space architecture. So the important thing is that, especially if the person can develop themselves by the existent programs and networks and study by themselves. So they cannot expect any education. So we see that there are like few universities giving some small educations about space architecture. So the important thing, as I said, to develop themselves by themselves, as making their network strong. I am working in this field more than 2-3 years, and my mentor, Dr. Summer, is supporting me in this way a lot. And the other community of space architecture, each of the space architects never hesitate to support. So never be ashamed to ask for help or for information, any document source for improving themselves. So just encourage to do. Thank you.
Which makes it like sessions and small communities like this being intercontinental and connected becomes more important, because first of all, there's no school for it. I mean, let alone in Indonesia, amongst thousands and thousands of campuses, we only have one that offer astronautics. So, aerospace degree related, and we have 270 million people, and that's why we do this. That's why we created Antaracta. But speaking of aerospace, we only have one. Architecture, we have way more, and we have a lot of architects. We have a lot of interior designers, but nothing on space architecture yet. So I think we're probably, I don't know, we have to check with Reva from the Architect Association. Is this your first space architecture session then?
Yeah, this is my first session with space architecture.
Yeah, so well, we hope that you can champion this as well in the Architecture Association, especially amongst the young architects of Indonesia. There is also AMI. AMI is Young Architect Indonesia, I think, Indonesia Young Architect Association, in which actually supposedly the host for today is one of the members, Ibu Daliana. She's a very well-known architect in the Netherlands as well, but unfortunately she cannot join us today, so she had to cancel. So it is a very new subject, not just internationally, but actually I wonder, I keep on seeing all these big architecture firms such as, SOM, and then I don't know, Jean Nouvel, whether they've done it or not, but definitely who else? Yeah, I mean the London one, who's it? I can't remember.
Yeah, Foster and Partners.
Yeah, Foster, exactly, Foster. So they've started, Foster, I think, did the spaceport in the US, right? Then America Spaceport, but big firms.
Also big architects from Copenhagen. They designed it like a Mars city in Dubai, and
with Icon.
Some proposals for Mars colonies. Yeah.
With Icon, the 3D
and this
printing
one.
tech, right? Yeah, that one. But I mean, like, what are the big architecture firm take on this? Is it still for? I mean, there's one exhibiting in Vienna as well. I think it was SOM. Are they really serious about this? Is it like requested, or they just proposing conceptual design, or what are the star architect approach towards space architecture?
I think for some of them it is marketing. I know for SOM it was kind of like marketing strategy, because they wanted to show that they are also like very progressive. After they have seen that Phosphorus got like so much attention for working with ESA, European Space Agency, they wanted to also jump on train. And in case of Big, I think for them it was like natural evolution, because they really have like very wide focus, and you can see that they think from like the history of biology on our planet to the very future, and you can really see that they try to implement space architecture in the portfolio for the long term. Yeah. But for example, in our case, we were always focused on the future, and I always saw the future in space exploration as kind of like the bright future, the scenario I would like to see. And definitely, when I was thinking about like several future visions, future scenarios, many of them can be quite dark. And I think it's important to focus on the bright scenarios, you know, and we have to work on these things while we can, because for us, I think it's a kind of like a launch window, and people waited, and the organisms on this planet waited for so long time before this was even possible. And now it's the right time when all the things came together that enabled to progress from our planet to other places, and we have to really grasp the opportunity and don't waste it, you know. And for us, this is what I do with our company. That for me, it's really like that I see this a huge opportunity for everyone, you know, and we really should be like taking part in this as much as we can. And there was an interesting previous question about the studies of architecture, if I may. You can study architecture, for example, on International Space University. I think we even had colleagues from Indonesia there. And you can study a master's program, which is like 1 year, which I did. And there is also a summer program, which lasts 2 months. And it is always on a different place on planet. For example, in the United States, Australia, you know, Europe. So you can basically study. You can get involved in space architecture studies very intensive program, and it is easy to get there, I would say, compared to other universities. And I think there is possibility to study space architecture in Houston at SIXA University. You can study space architecture in Vienna at Sandra Heuplik-Meusburger. And if you go to spacearchitect.org, you can see more opportunities for space architecture courses around the world. But I think there is also like many workshops and it's like short programs and so on. And it would be great, you know, if you organize something like that in Indonesia as a part of like maybe technical university or architecture university. And you have there like maybe one of the possible programs on the curriculum about space.
Okay, yeah. That's a long shot, but we will try from sessions first, workshops.
Well, I think it's the first step.
Actually, again, how do we know approximate ballpark figure now to build on the moon? That's just for one structure. With like 3D printing, do we have an estimate, rough estimate, how many $billion would that be?
It could be much cheaper than billions of dollars. But what do you think, Samir? Yeah.
Getting there is
even if it is like $10 billion, like, guys, come on. Do you know the expenses of just one F-22 Raptor jet plane? It's around $220 million just without weaponry systems. So 5 planes would be enough to build our first colony.
Yeah.
And F-35 is more expensive too, you know.
Yeah, there is money, you know, there is financing, but it's all about the political will, and it's not only for gaining elections votes. It's a political way, it's a scientific way. I think it's a must for our humanity. It's a very important. If you'd really like to take practical steps, just convince the private sectors and the entrepreneurs that there are resources that could expand their fortunes, and you will find the political will, you will find the energy, the manpower, the know-how, and the financing. And I think that is what is Elon Musk and Jeff Bezos and these guys are doing right now in the United States. The space trillionaires, it's a new notion that will evolve in the next few years. Not the Earth billionaires, but it's transcending into like capturing an asteroid of platinum or gold or whatever resource that you can find and bringing it back to Earth. It's a redefinition and rethinking of our own sustainability here, not depleting our resources, but entering to the field of Earth a new kind of resources. So yeah, it's a very promising. It has a lot. It will unlock a lot of potentials. So if you are paying like 1 billion, just in a few years, you will be getting tenfold this number. No matter about it.
I'm still more concerned about the physiology and our biology, or whoever astronauts that have to go there. But maybe because the moon is like close by, we can always commute.
Yeah, something, and this is a very interesting, really kind of thing that you brought to the surface. Yeah, we have to realize that our bodies are not engineered for space or to survive in space, but working along with, in parallel with, a space medicine will also unlock a lot of potentials. We are developing technologies to survive in space. The same science that will be used for our bodies to resist the kind of cosmic rays and radiation, it will be the same science that will be used to fight cancer here on Earth. So the evolution of what is known as the space medicine, the 3D printing on a molecular level, well, any kind who can afford 3D printing, his whole body corpse in the 25-year age is ideal shape, and he will be using this preserved body when he is in the 80s. He might need his lung or his heart or his whatever kidney. This is the new evolution. This is the new space medicine and space industries. So yes, I can see there is potential there. There is a lot of promising science that will be developed. We are just moving on a civilization scale of Kardashev from scale. We are approaching scale 1 type of civilization. There is a kind of scale that can measure the degree of advancement of civilization. It's called the Kardashev scale. Our current status is 0.73. We didn't reach type 1 civilization. I think with the space kind of technology and the space science, we can exceed the type 1 civilization and start stepping into type 2 civilization. And there is a lot of things that really, 200 years ago, just 200 years ago, people was pushing wooden wagons and pulling it with horses. You can't really understand the quality and the quantity of progress and advancement that had occurred just in 200 years. If you'd like to talk to one of the people that was living in 200 years ago and convincing him that we are landing on moon, we have stealth kind of ghost jet planes, it would be like science fiction. It would be like black magic for him. He can't really understand what you're talking about. Just in 200 years, which is a very tiny time span in our human history. We are 3.5 million years on Earth. Just in 200 years, we have advanced from something to a totally different level. And I do believe we don't need 200 years in the next future to advance to something similar. It might be in the next 15 years or 20 years maximum. So 2 decades. And remember, if we are still on this Earth, you will witness a lot of advancement that will be really amazing. Jaw-dropping kind of thing,
I mean, we had the space medicine session yesterday, and we're talking about our body resistance towards radiation, right? And today we're talking about how we're going to shelter, and what kind of structure we're going to be if humans are to live on the moon, with all of this anti-radiation material, whether, if it's like in situ or not. And then next week, we're also going to be talking about lunar radiation and how it impacts cardiovascular system. I
Very
think
important to be
and
attended.
that's like all the, that's why we try to
basically the
provide,
crossroads of all of the sciences. Yes.
yeah, we try to provide, and that's why we have the moon camp sessions, where we want to see from many different perspectives, and then eventually at some point, all of you all should be in one forum and talk about it. And I'm just gonna be the audience. Like, hey, you come up with something.
You are our facilitator today.
So because I think it's I mean, going there, the astronauts and the Apollo missions have been there a few times, commuting back and forth. You can do that in a week. So it cannot be considered as long term because, you know, some astronauts in the ISS, they stay until up to a year, more than a year, up to a year at least. But I don't know if you stay up to a year in the moon, that would be very interesting physiological changes. And I guess that's why, you know, then you have the option of living underground as well as on Mars. But anyhow, we can save that for another session. And if you want to learn more about lunar weather, lunar radiation, and then also how it impacts us physiologically, and you know, especially the cardiovascular system, it's going to be the session next week on planetary science, astrobiology, and space biology. 3 sessions, long hours with US speakers. They're all NASA researchers, and they're also sending the yeast experiment as well to test microbiome, whether they can withstand the lunar radiation. So that would also be interesting. That's also leaving Artemis 1 soon. But Ratri, do you have any conclusion, last minute messages before we close up?
No, thank you. I think just, yeah, as you said, wanted to remind everyone that we've got next week, we've got sessions on the 3 sessions that Anne mentioned on lunar weather and radiation, Moon to Mars, and the space biology as well. And then I think Dr. Samir, we also, if you're interested, on Saturday, 5 p.m. DST and 2 p.m. Indonesia time, there's a session on the in-situ resource utilization. So that might be of interest to you as well. So yeah, hope to see you guys join again.
And if you attended until now, you can sign off on our sign-off form to get your certificate of attendance. It will take time for us to process it. Please be patient, but good on you for staying from the start to the end. And we took pictures already. Thank you so much, Dr. Samer. Thank you so much, Tom. We'll schedule a catch-up call sometime soon for all of you. And thank you, Riva, from the Indonesia Architect Association, who apparently has gone missing from her screen. But we hope you can be our champion at the association to promote space architecture. And Ernest, thank you so much for the visual help. He will also be joining our Metaverse meetings as he's a creative director, documenter, and I'm excited to brew all of these ideas with all of you, and hopefully bringing Luniac before the end of the year. Yeah, Tom.
That would be lovely.
I miss going to Europe as well, but I think at this moment, even going to Jakarta is so much of a hassle. Okay, have a great weekend. Have a good day. Have a good time at the mountains, and we'll see you again. Ciao, ciao. Bye, bye.
Bye. Take care.
Thank you very much.
Bye. Bye, everyone. Thank you so much.
Bye.
Bye bye.
Okay, that's great. Oh my God, I have pounding headache. Crazy, this vaccine is killing me. Have you had your second, have you had everything like in Europe?
What do you mean?
The vaccination.
The vaccination.
I got 2 shots.
Oh, you got 2. I think if you have 2, then you're due to have the 3rd one, yeah. I just had my second one in Jakarta. Oh my God, I'm still live on YouTube. I'm going to close it.
Thank God I didn't speak. I was testing that on you guys.
Hang on, where is it? No. Oh, Bayu watched. Bayu is my friend. He watched from YouTube. Good on you, bro. How do I stop this YouTube? How do I do sound?
No, it's great that you managed to to do the event